All right, we're going to do a video now on changing dimensions. Let's talk about, we're going to talk first about the area of a rectangle. You know, it's the area of a rectangle is length times width. Well, what we're going to discuss is, what if we doubled the length? What would happen to the area? And what would happen would it happen every time? Okay, so for example, if we're to start out real simple, we have, instead of a rectangle, we have a special rectangle called a square. And its width is 1, its length is 1. The area then, you know, is length times width, which would be 1 square unit. That's 1 square inch or centimeter, whatever you want to call it. Well, let's go ahead and double the length, just the length. If we double the length, we'd have 2 going across. So our length would be 2, our width would be 1. The area then would be 2 times 1, which is 2. It's real simple. So the area is 2 square units. So when we doubled the length, we doubled the area. All right, let's double the width. See if that happens. See what happens then. If we double the width, you'll stack it 2 on top. We didn't double the length, so the length is still 1. So the area is length times width, which is 1 times 2, which is 2 square units. So when we doubled the width, we doubled the area. Okay, we'll keep going. Well, what if we triple the length? If you triple the length, it goes 3 across, and 1, the width we didn't do anything to, it keeps 1, and the area is 3. So when we tripled the length, we tripled the area. Let's triple the width, we triple the width, we triple the area. A pattern is here. Well, let's double both the length and the width now. Okay, if I doubled both, it's 2 and 2, and the area now is 4 instead of just 1. When I tripled the length but doubled the width, let's see what happens here. I triple the length, so it's 3 on the bottom, it's 2 going up and down the width. Then the area is 3 times 2, and it's 6 square units is the area. It's 6 times more than the original area. Well, let's triple the length and the width. That'd be 3 and 3. The area is 9, so that's 9 times more than the original one. If we do 4 times the width and length, we get 16, or 16 times more than the original one. All right, so beginning to see some patterns. Let's go ahead and write it all down. We make a chart. The length, here we have the original, the length, what the length is, and the width. All right, and then how many times larger is the area of the new figure than the original? Maybe I should have put the original in here, like the original length was 1, the original width was 1, and the original area was 1 square unit. 1 square unit. Okay, so when we doubled the length, the area was 2 times more. We doubled the width, the area was 2 times. We tripled and tripled, it was 3 times. When we doubled both, it was 4 times. When we tripled one and doubled the other, it was 6 times. When we tripled them both, it was 9 times, and 4 times, it quadrupled both, it was 16 times. So what pattern do you see? Right? You just see, well, it's just multiplying. You multiply those, whatever you doubled or tripled, you multiply that. 6 times 4, 4 times 4 is 16, 3 times 3 is 9, 3 times 2 is 6, that's 4, that'd be 3 times 1, because we didn't do anything, we just kept it itself, which would be times 1. That's 3, 3, 2, and 2, and that's how many times the area enlarged. Okay. Well, when we double one dimension, the area is doubled. Kind of what we just talked about. When we triple one dimension, the area is tripled. We just do one dimension, okay? When we multiplied one dimension by 5, what would happen to the area? It'd be 5 times more. All right? What effect does doubling both dimensions have on the area? The area is quadrupled. It's 4 times. What about tripling both dimensions? The area is multiplied by 9, because tripling is 3 times 3, so it's 3 times 3, which is equal to 9. What about if one dimension is tripled and the other is quadrupled? Well, one is tripled, the other is quadrupled. What do y'all think? It'd be 12 times. It'd be 12 times more. So in general, you just simply multiply how many times you tripled or quadrupled, or how many times you increased each side, and that would be how many times the area is increased. All right, next is, let's take a triangle now, okay? The original area is, of course, 1/2 the base times the height, so it's 1/2 4 times 6, all right, which is 12. Well, what would be the new area if the base was tripled? Well, we're thinking if one dimension is tripled, the area would be 3 times more. Let's see if that happens. Well, the area is 1/2 12 times 6, because now instead of being 4, it's going to be 4 times 3. That 12 is the 4 times the 3. Which is what we do when we triple the base. So that's going to be 1/2 of 12 is 6, so 6 times 6 is 36. So indeed, it's 3 times more than the original. One way to think about it, if you just simply put the new over the original and reduce it, that'll be how many times it'll increase. So for example, if we did what would be the new area if the height was doubled and the base was 4 times longer. Well, again, if you think about it, let's try to do it without even, let's do it this way. The height was doubled, that would be 2 times more. The base was 4 times more, that's 2 times 4. It should be 8 times larger, we're thinking. Well, the new height is 6 times 2, because the old height is 6, so times 2 is 12. The new base is 4 times 4, that's 16. So the new area is going to be half of 12 times 16, which is 96. Well, the area of the new triangle is new over original, so it's 96 over 12, right? The new one's 96, the old one was 12 up here. If we reduce it, that's 8 times larger, because 12 is in 96 8 times. But another way you could do it sort of short circuit way is just take how much it's doubled times how much each one was increased and multiply those together. Okay, last one about a circle. We're talking about a circle now, which is a little bit unique. All right, so now for changing dimensions of a circle, here we have a circle with a radius of 4, so the area is going to be pi r squared, and 16, which boils down to 16 pi. We'll keep pi just like pi, so we can just focus on the whole numbers. Okay, well, if we double the radius, what happens to the area? Well, here we have to think about something. When we double the radius, it's kind of like we double 2 dimensions, because the area of a circle is not length times width or base times height, but it's just r times r. So in this case, we're actually doubling 2 dimensions. When we double 2 dimensions, that's going to be 4 times. And that's what happens, because when you do pi r squared, you do pi times 4, and we said we're going to double it. So we're going to double it, which is equal to 8, but then we're going to square the 8. So we really did the 2 squared, okay, which makes it 4. And that's going to be equal to 64 pi. Well, so you ask yourself, 16 pi times what gives you 64? Or if you want to do the way we did it on the other board, it'd be new over the original. So the new is 64 pi. The original was 16 pi. Of course, the pi's are going to cancel, which is why we don't have to worry about them. So you think about 64 divided by 16 is 4. So this really is 4 over 1, or simply 4 times more than the original. Okay, for another example, if we triple the radius, that'd be 4 times 3 cubed, squared. 4 times 3, the whole thing squared. Which, in other words, that is what you're really doing. Let me just draw this here, it might help. You're really doing pi times 4 times 4 times 3 times 3. So you're doing it really 9 times more. This 4 times 4, that's the 16 that you had originally. But now you're tripling it, you're tripling the radius, but you have to square that. So you're really doing 3 times 3. All right? And that's how you come out to be 9 times more, because that'd be pi times 12 squared, which is 144 pi. So 16 times pi times what is 144, and when you divide, it's going to be 9. Or again, you could do the new 144 pi over the original, which was 16 pi. And again, those will reduce. And then you have 144 divided by 16, which is equal to 9. Okay? Hope that helps.